Kagera West, and I serve with the Foresight Institute for Research and Translation, FIRAT Rwanda, a multidisciplinary innovation engine advancing Africa-led development through science, technology, innovation, and knowledge translation. Today, I have the honor of introducing our agriculture program and the strategic mandate that guides our work. FIRAT was founded with a clear mission to close the gap between research and real-world implementation. We exist to ensure that knowledge does not sit on shelves as publications, but becomes measurable social and economic impact for African communities. Within this vision, agriculture is one of our most critical domains of action. At FIRAT Rwanda, our agriculture agenda is intentionally structured across 4 pillars: advancing food security and climate resilience through sustainable, adaptive farming systems; strengthening the link between agriculture and human health, particularly for women, children, and vulnerable households; unlocking value chain innovation and agribusiness to drive income, employment, and farmer-led entrepreneurship; and building capacity, especially for youth and women, to equip the next generation of African agricultural leaders with modern, scalable technologies. A distinctive emphasis of our strategy is the elevation of underutilized legumes and orphan crops, foods historically neglected by mainstream systems but rich in nutritional value, ecological resilience, and market potential. This commitment was reinforced at the recent 8th National Stakeholder Summit on Underutilized Legumes at IITA, where FIRAT participated actively. The summit made one point unmistakably clear: crops like the black and red Bambara groundnut are not the future, they are the urgent present. Naturally drought-tolerant, nutrients-dense, globally trending for their health value, and capable of fixing nitrogen to enhance soil fertility, these legumes are climate shock absorbers, health assets, and economic opportunities all at once. However, the opportunity is matched by practical constraints. We are still contending with hard-to-cook varieties, a near absence of mechanized processing, weak market linkages, limited access to credit and quality inputs, and a shortage of high-yielding varieties ready to deployment. This is why FIRAT Rwanda is working collaboratively, not hypothetically, but immediately, to drive action across 3 priority fronts: genetic improvement and breeding of crops like pigeon pea and Bambara to improve yield, reduce cooking time, and accelerate adoption; technological innovation, including vertical farming and rapid multiplication strategies tailored to African realities; and extension and communication reform, deploying not only traditional field agents, but digital channels, influencers, and rapid reach formats that ensure knowledge reaches the last mile. Together with national governments, international research institutes, farmer organizations, and private sector partners, Professor Miftahoudin and our broader FIRAT Rwanda team are committed to turning these summit insights into deployable, scalable, evidence-based solutions for Rwanda, for Nigeria, and for Africa at large. This is not a theoretical conversation about agricultural transformation, it is an implementation agenda, and today we invite you to be part of building that future with us. Before we move forward, it is my privilege to introduce the moderator for today's session, a man whose life's work reflects not only academic excellence, but a profound devotion to African agricultural transformation. Professor Abdurraouf Miftahoudin hails from Atiba local government in Oyo town, and his journey from Alafia Nursery and Primary School in Ibadan to becoming a full professor of agricultural production economics is a testament to unwavering purpose. With a BSc and MSc from the University of Ibadan and a National Youth Service year in Sokoto that earned him a State Merit Award, he built a formidable foundation in agricultural economics long before the word innovation became fashionable in development conversations. Since joining Ladoke Akintalota University of Technology in 2004, Professor Miftahoudin has risen through the ranks with remarkable speed and clarity of vision, from assistant lecturer to full professor in 2018. His work, deeply empirical and impact-driven, focuses on resource and agricultural production economics, interrogating the low productivity of African farming systems and identifying precise, scalable interventions to reverse that trend. He is an ardent advocate of technology and knowledge transfer between African countries, not as theory, but as an urgent implementation agenda. With over 60 peer-reviewed journal publications, extensive leadership experience at Ladoke Akintalota University of Technology and the University of Swaziland, and a powerful mentoring footprint, having supervised more than 150 undergraduate and 28 postgraduate students, Professor Miftahoudin is not just a scholar. He's a system builder, a communicator, and a relentless believer in the future of African farmers. Ladies and gentlemen, it is my honor to hand over to the moderator of today's session, Professor Abdraouf Miftahudin. Professor, the floor is yours. My name is Mira.
Thank you very much. You are all welcome to this month's webinar on agricultural sensitization. I will now introduce the lecturer for the day, Dr. Ismail Muritala. Dr. Ismail Muritala stands as a dedicated lecturer and examiner whose professional life bridges the gap between advanced animal biotechnology and practical agricultural development across Africa. With a PhD and master's degree in animal biotechnology from the Federal University of Agriculture, Abeokuta, Nigeria, and a foundational bachelor degree in animal science from Obafemi Awolowo University, his academic pedigree is firmly rooted in the continent's agricultural future. His deep specialization spans animal health, microbiomics, genetics, and biotechnology areas critical for enhancing food security and resilience. Currently, Dr. Muritala contributes to global research as a postdoctoral research fellow at the University of Zululand, South Africa, a role he holds concurrently with his position as a lecturer at Osun State University, Nigeria. This dual affiliation underscores his commitment to both cutting-edge research and knowledge dissemination. His practical experience is extensive, ranging from serving as an agricultural extension volunteer for the Empower Agri program to working as a field supervisor, demonstrating a hands-on understanding of farm level and community needs. Dr. Muritala's research portfolio, comprising 15 publications, showcases a focus on solving immediate and future challenges facing agricultural livestock. His work on pests, petits ruminants, virus detection in West African dwarf goats, and his analysis of the genetic and non-genetic factors affecting its prevalence highlight his role in protecting key agricultural assets. Furthermore, research on the role of effective microorganisms in broiler production and the analysis of deep learning algorithms for predicting poultry diseases demonstrate its engagement with innovative, technology-driven solutions, a perfect fit for the focus of modern agricultural transformation. Beyond the lab, Ala is an active member of the academic community, serving as a reviewer for scholastic journals and actively mentoring postgraduate students. His pursuit of continuous development is enhanced by numerous specialized workshops attended, including training on I5 backbio sequencing, animal research ethics, and the application of RStudio in data analysis, which solidifies his command over the numerical and ICT goals of modern agricultural practice. His receipt of a Travel Fellowship Award to the International Society for Animal Genetic Conference further attests to his recognition on the global stage. In summary, Dr. Ismail Muritala is a dynamic scholar and practitioner, combining advanced expertise in genomics and animal health with a proven ability to engage in agricultural extension and policy-relevant research. He's precisely the kind of expert needed to lead discussion on technology and innovation in modern agriculture and the crucial role of policy governance and community participation in agricultural development demonstrated by his confirmed roles in the master's class webinar series. I will now call Dr. Ismail Muritala to take the floor to give us his presentation on the particular topic, understanding the innovation of technology, understanding the technology and innovation in modern agriculture. Dr. Ismail Muritala, you have the floor now.
Thank you very much, Prof, for the kind introduction and for reading my citation. Good afternoon, good evening, and good morning, wherever you are joining this presentation. It is my pleasure to speak on this topic, understanding the role of technology and innovation in modern agriculture. This is an attempt to sensitize us on shaping the future of food production. Okay. Yeah, this is the outline of my presentation, where we're going to discuss history of agriculture, how it started, and the transformation that has taken place over many years, up until the challenges and ethical considerations on the innovation and technology advancements in that we have in agriculture. History of agriculture. The history of agriculture is telling us about the story of humanity's gradual shifts from hunting and gathering of agricultural produce, be it from crops or animal. In those days, it used to be people go into the wild or forest to fetch all these materials, to use as food and for other materials. And these generations have been subdivided into different eras. The first era we could recognize as the Neolithic Revolution, whereby people stop going into the wild. Not that partially stop going into the wild. They have started cultivating crops very close to their to where they live, and they started domesticating animals in order to make food available when they are in need of them. And that is at the time when we can formally say that agriculture, actually started. And this happened in 10,000, before before Common Era, up until 8,000 Common Era, and thereafter we have the early agricultural civilization, which occurred between 5,000 to 1,000, before Common Era. And this actually witnessed a period when people started using some simple implements in order to ease the agricultural activities and in order to improve the productivity of their farming system. Followed by early agricultural civilization, we have a classical and medieval agriculture, which occurred between 1000 BCE up until 1500 CE. At this point, that is when men started using innovation to improve the agricultural productivity. They introduced mounting collar on the animals like cattle, horse, in order to prepare soil for agricultural production. When they mount this implement on the animal will be drawing it, and as a result of that, the soil will be pulverized, and this will make the agricultural cultivation, crop cultivation, more easier than it would have been. The advancements upon this classical and medieval agriculture is what led to the agricultural revolution, when people started applying different methods like crop rotation, irrigation, plowing in real time into the agricultural production for them to be able to have more yield from their crops, and in order to ease their production. This went on up until when the modern agriculture was, came into being from 20th century up till present. And this modern agricultural era as many components. Under this, we have at a time when we have a mechanization, during which tractors, herbicide, tractors, harvesters, so many equipment were produced at this era. During this era, when in order to improve agricultural production, a land that could have been taking months to be cultivated can, with the use of an harvester and some other few days equipment. This innovation evolved up until we now have the green revolution, which took place between 1940s to 1970s. At this period, this is when we have many advances in biological sciences and the development of many chemicals like herbicides, pesticides, fertilizer, inorganic fertilizer, and so on. However, this green revolution, was accomplished, came with a lot of challenges, or what we could recognize as shortcomings of this development, whereby we have soil degradation, the excessive or indiscriminate use of herbicides, pesticides, and some of these chemicals, came with a lot of shortcomings like soil degradation, soil pollution, water pollution. Many inhabitants of soil that were supposed to be beneficial to the plant, at this point they were being negatively affected. So that shows that the era of green revolution were not sustainable. It did not guarantee sustainable agriculture. And I think that was what led to another innovation, which we are now seeing today. So after green revolution came biotechnology and genetic engineering, whereby you can develop plant varieties, you can develop animals for a specific purpose using principle of genetics. Also, after the green revolution, we also have sustainable and digital agriculture, which we are going to discuss better during the course of this presentation. Yeah. Why do we need to change the way we do things? You cannot be doing things in a similar way and be expecting different results. It is impossible because things cannot just change unless you bring new ideas or new ways of doing things that can guarantee better productivity. When you look at the prediction of this man, he was an economist, Thomas Malthus. He emphasized that the way the human population was growing at that time, if it's outpace the food production, then there will be widespread starvation, there will be famine, there will be hunger in the land. However, the critics of this guy now said, okay, yes, what you are saying might be true. However, because of the innovation and technological advancement, this will be mitigated using innovation or bringing in innovation and the application of technology. And that is exactly what we have been experiencing over the years, and is what we are seeing presently. So why do we need this innovation? Is because the population of the human population keep increasing every now and then. It has been predicted that the world population will increase to 9.7 billion by 2050. Looking at this figure, one may say that this is just a statistical might. This is the way they say it all these statisticians, they can mention a figure and it's just a prediction, it may not happen. But let me tell you, this might be a reality, because in 1960, when the human population was this thing is not moving. Okay. In 1960, when the population was 3 billion, at that time, when they tell us or they predict that the population, the human population would increase to 9.78 billion we are seeing today, I believe some people at that time will, they want to contest that. They would have contested that this is just a prediction, it will never happen, and it's a reality today. And that shows that a prediction about the human population will increase to 9.7 billion by 2050 might be a reality. So if this come to pass, then there must be an effort in place in order to to make provision for the extra mouths that will join the existing population, in order to avoid food insecurity at that period. We are already experiencing food insecurity. In some part of the world, there is a famine, there is a widespread starvation and all that. So in order to mitigate all this problem and to mitigate future problem, there is need for innovation and technology advancement in agriculture. Yeah, as we said, in those days, the farming system, agriculture, is based on experience and tradition. This is the way we found our forefathers doing this practice, and that is the way we will be doing it. This will never take agriculture into where we want it. We want agriculture that will be sustainable. We want agriculture that will be able to guarantee food security to the general public. Thus, we must find a way of enhancing this productivity, and that is the reason why the agriculture is moving from using tradition or experience-based practice to data-based practice. The digital farming that we are talking about is a database. It relies on data analytics. It relies on data analytics. We are going to see that later. Then another reason why we must, be up and doing about the innovation and technology is because the climate change, the effect of the climate change on the agriculture is so devastating. There was a particular year like that in Nigeria that some farmers, planted, and there was no rain on this crop, and eventually at the end of the day, they did not harvest. They did not harvest anything from their efforts, from their farming efforts. So that is to tell us that we need to find a way of mitigating this problem in the future, if at all we are concerned about the problem of food insecurity across the world. And permit me to say this quote, that the farmers of the future will be much data analysts as they are, cultivating the land. The smart farming we are talking about relies on data. So for us to be able to guarantee precision agriculture, we need data. We need data to build models that will be able to guide us in formulating ways, or guide us or recommend better ways of farming, or taking appropriate action at at a particular point in time. So that is why we are saying that the farmers, most of the, even the less educated ones, will be sensitized to the extent that as they are carrying out different activities on the farm, they will collecting data all along, because it is this data that will be used by machine learning to be able to predict or to recommend the activities that can be taken to mitigate problems facing the agriculture. Yeah, defining modern agriculture. We are talking about modern agriculture today. What modern agriculture entails is what it entails are the digital tools, biotechnology, and sustainable practices. It is the integration of all these different practices that make up what we call the modern agriculture. Digital tools, there are wireless sensors, network. There are sensors that are used in agriculture today to take images, images of animals, images of plants, particularly in order to monitor disease in plants and animals. This technology take pictures. They take numerical values about the climatic factors, temperature, humidity, wind pattern, and so on. For this data are taken to the machine, particularly Python and the MATLAB, for analysis. The machine are trained on this data, that when you see certain images, this is what it implies. The machine are trained on this, and once they see it in the future, they will predict and tell you this is actually what the problem is, and that is what we call precision farming. They will tell us based on the training, the ad from the data collected on the field, and they can advise the farmers based on that. Yeah, let's look at biotechnology and genetic engineering as part of innovation and technology in agriculture. What brings about genetic improvement is that we want our plant varieties, we want our animal breeds to be able to perform better than what they usually do, or what they can naturally do. Sometimes the reason might be because we want them to perform a specific function for us, like what we have in genetically modified crop and animal or organism, whereby certain genes are taken from another species and inserted into that crop or animal for them to be able to perform better. So that is the basis. That is the basis of genetic engineering. Genetic improvement. And this genetic improvement, in the past, it used to be conventional, whereby several crosses of individuals, several crosses are made from different individuals based on the features they possess, and the breeder knows the target, where he's going. So there is already breeding goals. So the breeder will breed towards that breeding goal. But the problem of this practice is that it takes many years, takes several years before you can achieve, before this breeding goal can be achieved. However, the advancements, the innovation in science now bring about biotechnology, whereby genes, the exact genes that you actually want to, you are carrying out crossbreeding, which is your target, why you are carrying out crossbreeding conventionally, can be taken using special tools and insert into the species or organism where you want it. For instance, the genetically modified organism, genetically modified plants like BT maize. BT maize is legalized in most of the countries like America and some other countries, even including South Africa. They are using it. They are consuming BT maize. What this BT maize? How is it produced? The BT maize was made out of it's a kind of maize produced from a gene. It's a maize produced by modifying a maize plant incorporates a gene from a bacterium called Bacillus thuringiensis. That gene that genes influence production of protein that is poisonous to insects, particularly the corn borer. So when this gene is incorporated into the genome of maize, then the maize, when the maize express this gene, it will have the ability to chase away a corn borer in the feed. So as a result of that, the costs we spent on herbicides, insecticides, which will later cause problem, sustainability problem, because when you apply chemicals on in the feed, a lot of organisms will die. Some of these organisms are beneficial organisms, particularly the microbes, they will die. And by using this technology, we are saving the life of this beneficial organism, and as a result of that, we are we are encouraging, we are maintaining the sustainable agriculture. So this will reduce the cost of production of maize, and also it enhances the growth rate of the maize, and this will the outcome would be higher yield from this particular production. Another example is that of herbicide tolerant soybean. Herbicide tolerant soybean. Well, this gene is taken from Agrobacterium tumefaciens. This gene, when it was incorporated into soybean, it will enable the soybean to have resistance against herbicides. So when the farmers spray herbicides on the feed, the herbicides will not be able to kill the soybean, but will be easily, will be able to eradicate all the weeds on that feed. So with that, we are saving the life of the soybeans, and the soybeans will be less affected with these chemicals, and we have more yield from the soybean. Also, we have a genetically modified animal as well. For example, we have the Aqua Advantage salmon. The Aqua Advantage salmon is a kind of aquatic animals that are used for food. But this animal, particularly the Atlantic salmon, it has a specific period when it is grown. But for us to be able to have this species all year round, the thought of getting a gene from the Chinook salmon and a promoter from an ocean pound. So when these are incorporated into the Atlantic salmon, it will enable it, and this animal express this gene, that it will enable it to live throughout the year, and making it available throughout the year. There is also production of Evaro pig. In Evaro pig, the gene that was used to modify the genome of pig was taken from the E. coli, the common bacterium, and the promoter from a mouse gene was used in order to make this gene to express or to replicate in the pig cell. And at the end of the day, they were able to produce a pig that are able to, digest phytase better. And as a result of that, this reduced the amount of phosphorus that are released into the environment, and by doing that, the pollution, which, by the feces, are drastically reduced. This is one of the benefits that we get from biotechnology and biotechnology in animal production and plant production. So today we can modify the genome of plant for a particular purpose. We can modify the genome of animal for a specific purpose, either to enhance the productivity or to enhance the resistance of that animal or plant against disease, or to make them resilient against the changes that occurs in the environment. Yeah, one of the innovation and technologies that have taken place during modern agriculture is this biological control. So instead of using chemicals to control weed, to control insects, we can as well use biological technology. There is a technology called push-pull technology. This push-pull technology is an integrated pest management, whereby we have two components which are the push component and the pull component. Or push component is a plant, push component also is a plant. Then we have our main plant. The push component will be planted, will be intercropped with our main plant. For instance, here we have maize plant as our main plant, and the push plant are the Desmodium species, which when we say push, it means repel. So it's push away the stem borer. It's push away the stem borer motes, and as a result of that, the maize plant will be free of stem borer, because this Desmond species will secrete a kind of hormone that will send away the stem borer from the feed, and it also enhances the fertility of the soil, thereby improving the growth rate of the maize, and as a result of that, the yield or the output at the end of the day will be encouraging. Then also we have the pull component. The pull components, for example, we have the Napier grass. This Napier grass it has a pheromone. It has a kind of hormone that attracts, that pull the stem borer towards itself. So when the stem borer lay egg on this, they are non-fertile. So the eggs will not be able to develop further. And as a result of that, these plants are pulling the stem borer away from the maize. It's one of the technology that have now developed today. They are using it in different part of the world, and it saves the cost on the cost on pesticides. And apart from that, it guarantees sustainable agriculture, because the soil degradation, soil pollution that occur as a result of the excessive use of chemicals will be eradicated using this technology. Then comes the smart farming using computer-based technology. If we look at this slide, we are seeing drones, we are seeing tractors that are being driven by itself. These are the newly developed technology, and it is not just a magic. These are the products of data collected on the farms, and the machine learning have been trained in order to develop algorithm, in order to develop a specification, machine specification that can help the farmers to solve a lot of problems. Drones are released drones are released onto the sky, and it take pictures. These pictures are processed in Python, in MATLAB, in order to develop algorithm, and from that algorithm they develop a kind of a chip that can be incorporated into any device, be it a smartphone or tablets, such that when you take it to the field, you can do a lot of things with this technology. Maybe to diagnose disease, pathogenic plant disease. It sensitizes and enable farmers to know possibility of disease outbreak even before the sign and symptoms of clinical sign, before humans start seeing the clinical signs. It can be used to detect very early, detect disease in plant and animal as a result of the training that this machine have gone through from different data collected on the farm. Most of these data are images, they are numerical value. For instance, you can collect numerical values on pulse rate of animals, rectal temperature, so many health indicators. You can have data on health indicators from animals, and this data can be taken to the machine learning, and machine learning we can train the machine learning on this data, and then when the machine learning analyze this data, it can develop an algorithm that can be used to detect the health issue associated with that data that was supplied to the machine. This is part of the smart farming that we are talking about. You see sensors who are being mounted on the farm. It can be mounted on the wall. I mean, on the pen, on the pen, or it can be mounted on the tractors. It can be mounted on drones. It can be mounted on any device, and this will be capturing images. It will be capturing images that will be used as data to train the machine to train the machine, and from that data which the machine was trained with, the machine can develop a kind of algorithm or chip that can be used to precisely recommend or advise farmers on the activities to be taken in order to avoid outbreak of disease, or in order to guarantee smart farming. There are some sensors that collect data about climate factors. I mean, climatic factors like temperature, humidity, rainfall, and so on. This data, when the machine learning is trained with it and analyze it, it can be used in it can be used. The result from it can be used to advise farmers on when to plant in the next season, and it can also guide the farmers on how to go about irrigation. Sometimes, in the past, irrigation are done blankly. They are done blindly, where the amount or the volume of water that are actually needed on the field are not known. So with this smart farm and based on the data, available data to the machine, it can recommend the exact volume of water needed by the plant in order to maintain a better growth, better yield, and sustainable agriculture. With that, we benefit a lot, because no water will be wasted at the end of the day. It is only water that are necessary or that are required by the plant, for the plant uptake, that will be dispensed onto the farm. Also, this sensor, smart sensor that we are talking about, the wireless sensor network, can also guide us about the nutritional requirements. What are the nutrients that are deficient in a particular soil at a particular region? This will guide the farmers on the amount or the type of fertilizer that should be applied on the farm. So with this one, you don't have to collect soil sample and take them to the laboratory. And I think because of this issue surrounding soil analysis through laboratory practice, I think that is what prevents or discourage most of the farmers from carrying out this soil analysis before they start planting things on their farms. And this is not has not been going well with the farmers, because the soil requirement for each plant varies. So farmers are not planting on the soil based on their requirements, because they don't have that knowledge. And even if they know, the stress of going to the lab today and going to the lab tomorrow for collection of results will prevent them from going. But with this technology that is able to tell us the nutrient composition of a particular soil and the nutrient requirement of a particular crop, based on that, is able to recommend to us what kind of fertilizer, what is the quantity of fertilizer that is required at that period. I think this will be more friendly than the usual practice or the old practice. So that is what this precision agriculture is all about. There are some wireless sensor network that collect data using GPS, and there are some that collect data on the climate, like I said earlier. Based on that, the recommendation or advice could be given right advice can be given to the farmers on when the planting activities should take place. Then what other activities can be taking place? That can be taken at a point in time or the other. So with this technology, I think we are moving towards precision, most precise agricultural production. With this, it will reduce the inputs that we waste as a result of gambling. Sometimes the farmers will plant, and at the end of the day, they will not. I mean, there won't be rain to fill the plant or to make the plant grow. As a result of that, there might be total loss from that activities. With this technology that can guide us, okay, this is when we are going to have rainfall. This is what the weather will say tomorrow, and so on and so forth. This will guide us on the precise activities that can be taken at the farm at a particular point in time. This image is showing us how the how the data are being collected from the farm, and the data are being used to carry out so many activities on the farm, like the tractors. Just like the tractors we are seeing on the farms, some of them, I mean, these tractors are self-driven. They are trained to do that. They are trained to do that based on the available data that have been collected on the farm. And they will perform these activities based on the programs or based on the instructions contained in the software implanted in this machine. And most of the time, the precision in their activities is so high to the extent that we can no longer go back to the usual way we used to do agriculture in those days. So this farming practice is making agriculture more friendly, more precise, more productive, and more profitable. Then there is also, I think I mentioned this the other time, automation and robotics, where we have tractors that are self-driven. We have different machines that can operate, that can be operated without anyone, mounting on it. Even though there might be a device somewhere controlling it, or an instruction or software or a chip implanted in that machine in order to control the activities of this machine. This has enhanced and it has improved the way we do agriculture, and it has guaranteed sustainable agriculture. Now, this is also part of the automation we are talking about, the Internet of Things. The Internet of Things in agriculture are the physical device materials that are interconnected over the internet. You can sit down at your home and be controlling things in your farm. That is the innovation, that is the technology that we are now benefiting from, the IoT in agriculture. It has eased so many activities on the farm, and as I said earlier, they are not just magic. The activities of this machine or of this technology are based on the data that have been stored and analyzed in the machine. So this is part of the IoT we are talking about. Then data analytics. This will produce model that we predict how we can carry out activities or farmings in a more productive way, and it can also predict the yield that we can get from a particular hectareage of a farm. With this technology, I think the agricultural production can improve and is actually improving because we are doing things in a more easier way and in a more productive way and sustainable way. These are the innovation that has occur or taken place in agriculture over many years. Yeah, to make for the acceptability or to make this technology available to the farmers, there is need to share this technology by educating farmers on how to use this technology, effort by all stakeholders, government, national organization, institution of higher learning, and so on and so forth. They come together to ensure that the farmers are well educated on this technology. Most of the farmers today, they speak against GMO, genetically modified crop, genetically modified organism, and so on and so on, because they don't have the correct knowledge about this technology. So they need to be educated. Even the smart, the IoT farming that we are talking about also, if the farmers are not properly educated, there is possibility for them to go against it if they are not properly educated. These people are they are the end users of this technology. They need to be educated and they need to be carried along in the formulation of all these policies that will enhances the use of this technology in agriculture. So from the image we are seeing on the screen, you can see people are now using their device to take pictures, analyze that pictures, and predict what could be the problem of plant. They can use it to predict what kind of disease that particular plant may likely face in the very shortly. So this is part of the smart farming we are talking about. This is smart farming in Kenya, whereby smart phones are being distributed to some farmers, and they are trained on it. They are trained on how to use it, and as they are using it, it will guide them on so many practices on the farms: cultivation of weed control, irrigation, when to do the harvesting, and what they should be expecting at the end. As the yield from their cropping activity. From their production, from their crop production. So these are the innovations and technologies that agriculture generally has witnessed over many years. I want to put end to this discussion from here. So if we have questions or comments from our audience, so we want to give us that opportunity to ask question, because I can see I've spent over an hour. But just before I conclude this discussion, this is the key takeaway from this presentation. It is a known fact that the technology and innovation are transformative tools that have taken place over many decades, and not a replacement for human. It is not technology cannot completely replace human ingenuity, because this technology we are talking about must be controlled and regulated and driven by human ingenuity. Be it machine learning, be it artificial intelligence, artificial intelligence will give you reports, will give you information based on the prompts that is given to it, based on the data that the artificial intelligence has been trained with. So the fear that technology will replace human shouldn't be entertained at all. Then with technology advancement in agriculture, there will be sustainable food system, and this depend on the innovation and inclusivity and resilience of our people. Also, modern agriculture is not about machine replacing farmers, as I said earlier. It is about empowering them with machine to feed the world smarter, to feed the world easier, to feed the world sustainably and responsibly. Thank you for your audience. And if we have any question or comments, you are welcome to bring out your question, to ask your question.
Thank you very much, Dr. Ismail Muritala. We are very, very grateful for these insightful discussions. You have opened our eye really into understanding the role of technology and innovation in modern agriculture. You try to chronicle it for us from the early days to the modern time. More so when the world population is increasing very fast and we don't have an option other than to engage technology and innovation in modern agriculture for food security and food sustainability. And the lecture is very, very insightful. The audience have a lot of questions. I think you can see it. Can you?
Yes.
Yeah.
Yes, I can see that.
You can take the question one after the other to answer those questions. I think the first one I'm seeing there is how are institutions like IITA and etc. in Nigeria advancing these revolutions in agricultural practices?
Yes, thank you, the person that asked this question. I know very well that IITA is doing very, very fantastic well on this part of technology, particularly on the biotechnology and genetic engineering. I could remember during my bachelor's degree days, we went to IITA and we saw what the kind of technology they are using for the improvement of plants, because IIT is basically on plants. I think they have a sister institution called IRI, International Livestock Research Institute. IRI they have a building beside IITA. So basically, IITA is doing well, particularly on genetic engineering, tissue culture. They've developed several plant varieties that are being, breed, or that are being produced for a specific purpose, either for resilience or for higher production. They've developed different cultivars of cassava, different varieties of maize, wheat, and so on and so forth. So they are doing fantastically well. But in terms of smart, the IoT in agriculture, I wouldn't know the kind of development that has taken place in the IIT presently, but that is how far I would say about IIT. I know that they have done creditably well on genetic engineering and biotechnology in agriculture. So for the second person asks the question, how can research locally help showcase the advantages of these sophistications. Like I said earlier, it requires the involvement of many stakeholders. People have developed several devices that could be used directly on the farm. I could the my research for my the research for my PhD, one of the components of my research was to use molecular diagnostic, molecular method to diagnose PPR in small ruminants, a technology that was modified for developing countries, where we cannot have where sophisticated laboratory are not available. So even then, we face a lot of challenges with that lab test that molecular assay that we use. With this smartphone, if there is if the information or data have been trained with machine learning and is able to develop this algorithm, this can be put or placed in the smartphone, which any farmers can use on their farms. You only need to put direct the sensor onto the animals or plants, wherever, whatever you want to use it for. You need to direct this sensor onto it, and it will capture so many data, analyze this data, and tell you what will happen to this plant or animal in few days. So that technology to be adopted or to be available to the farmers, it means that government has a role to play. The NGOs has a role to play. The philanthropists have a role to play. So many people have, many stakeholders have roles to play on this to be able to step this technology down to the farmers, that actually need the technology.
Okay, can you see the next question on how can we?
Next question is saying, how soon do you think Nigeria will get to this level of sophistication in agricultural practice? Well, I would say this question is political. We cannot really say, because telling you that it will take us so many years, it will be as if we are speaking against the government or we are speaking down on government. But I want to believe that gradually we can get there. I know recently this National Center for Biotechnology, they have started distributing GMO maize, GMO, either cowpea or soybean, to the farmers. So it means that we have, they have identified this potential. They have identified this technology. They have. I think everything is gradual. I think with commitment and consistency, we'll also get there one day.
Okay, I think that's the last question here on the chat. I don't know if our audience have one or two more questions before we round this month's webinar up. If there are no questions again, I would like to thank our presenter, Dr. Ismail Muritala from University of Zululand, South Africa, for this wonderful presentation. And I believe that if you are invited again, because we enjoy your lecture, to come on this monthly webinar on agricultural sensitization, you will not deny us the opportunity. Once again, we are very grateful. Likewise, I thank Firat for providing this platform to be able to have this opportunity to know more about understanding the role of technology and innovation in modern agriculture. Thank you very much for the opportunity you have given each and every one of us. All those who are here that are in the house to listen to this, we thank you also for being part of us, and we believe that the next month presentation, you also join us in this room by the grace of God. So we will let you know, though it is there in the circulation, how the programs were being scheduled on a monthly basis, just for you to be able to keep track of the monthly webinar series by FIRAT. So after giving this vote of thanks, I would like to round up this presentation for this month, and we pray that next month we'll be here and even invite many of our colleagues, our friends, and relatives to come and benefit from this wealth of knowledge, because food security is very, very essential, and we have to talk and work it, just like FIRAT is trying to do. This is one of the ways by which FIRAT is trying to contribute to food security and food sustainability. And by the time other programs also come from FIRAT, I know we'll be able to join the programs for the benefit of ourselves and humanity at large. Thank you very much again, and I wish you a safe return to our different places. Thank you very much.
Thank you, Prof.
All right.